Today we're going to learn about absolute value equations. Absolute value equations, so how it works is when you take the absolute value of a number, you always end up with a positive number, or 0. So whether the input was positive or negative or 0, the output is always positive or 0. For example, if you take the absolute value of 3, you're always going to get positive 3. Or, like we said earlier, if you input a negative, like here negative 3, you're always going to get a positive. So it's always positive 3 in this instance. This property that both positive and negative become positive makes solving absolute value equations a little tricky. But once you learn the trick, they're not so bad. So let's start with something simple. So, solve the absolute value of x if it equals 3. So, what we're going to do here, you need to use the negative property, the positive or negative property of the absolute value to split the equation into two cases. We're going to do that down here. So what we did, when we saw the absolute value sign, we knew that regardless of what you put into, it's always going to be positive. So just like the examples up here, I could put in positive 3 or negative 3, take the absolute value, and get 3. The minus sign, negative, indicates the opposite sign, not necessarily a negative number. So remember, when you see absolute value, you should be able to put in a positive or a negative and always get positive. For example, if you have x equals negative 6, then negative x indicates the opposite of x, or in this case, negative of negative 6 equals positive 6. So, the minus sign in negative x just indicates that you're changing the sign on x. It does not indicate a negative number. So remember, when you see absolute value and you have the negative sign, like we see in here, we just know the absolute value means do the opposite of that number. So the opposite of negative 3 is positive 3. Absolute value equations always work this way. To be able to remove the absolute value bars, you have to isolate the absolute value onto one side and then split the equation into two possible cases. We can also verify the above solution graphically. When you attempt to solve the absolute value equation, absolute value of x equals 3, you are in effect setting two line equations equal to each other and finding where they cross. In this case, as you can see below, so can you guess what you're going to see? This is what we get. We see this is an absolute value graph. It's pointed, it looks like a V because it starts at 0 and then the intersection is at negative 3, positive 3, which gives us the two lines, y1 and y2. So fill in those lines right now. Okay, all of these just verify what we just did.
Daniela Peña, please come to.
If x equals negative 3, then absolute value of x equals absolute value of negative 3, since we just plugged that in here, which equals 3. Remember, absolute value of the negative means do the opposite, which gives us positive 3. Then, if absolute value of x equals absolute value of 3, if x equals 3, we still get 3. Let's look at more exercises. So I want you to solve absolute value of x plus 2 equals 7. To clear the absolute value bars, I must split the equation in its two possible cases, one case for each sign. So remember earlier how we always had a positive and a negative for an input for absolute value, and it would still be true because it would turn out to be positive. So we start out with positive x plus 2, and then we also have negative x plus 2 because we know from absolute value it can go in both directions and still be true. So what happens when you solve this? You get x plus 2 equals 7. You subtract 2 from both sides, and 7 minus 2 is 5. On this side, you have to distribute the negative sign. So when you distribute it, it becomes negative x minus 2 equals 7. We add 2 to both sides to cancel out the 2 on this side. 7 plus 9 is 7 plus 2 is 9. But since the x has this negative sign, we divide both sides by a negative, and that leaves the negative on the 9 side. So the solution is x equals negative 9, comma 5. This is a key point. So you want to make sure that your absolute values have two values when you're doing these types of problems. To confirm this graphically, you would look for the intersection of y1, x plus 2, absolute value, and y2, y2 equals 7. And this is just going back to our equation. So what happens when we take the absolute value of x plus 2 and then set it equal to the other side of the line, 7. So here's 7. It's a horizontal line, and then here is our negative value because it intersects at negative 9, so it would be this equation, and then here is our positive value because it intersects at 5, so here it would be this equation. See how it intersects here at 5 and then here at 9. So please write that down in your graph. Okay, let's try just a few more. Solve for absolute value 2x minus 3 minus 4 equals 3. So first, I'll isolate the absolute value part. So I'll get the absolute value expression by itself on one side of the equal sign with everything else on the other side. This is just a basic algebra problem. We want to get rid of this extra negative 4, and we're going to carry it over to that side by adding, doing the opposite. Here's what we get. We get absolute value of 2x minus 3 minus 4 equals 3. If you add 4 to both sides, you get 7. So now I'll clear the absolute value bars by splitting the equation into its two cases, one for each sign. Just like we did earlier, you always have to split it into two cases, the positive, the negative. So fill this out, 2x minus 3 equals 7. So we add 3 to both sides, we get 10. 2x equals 10, we divide both sides by 2. 10 divided by 2 is 5. Here we distribute the negative. So we get negative 2x, the negative times the negative equals a positive, so positive 3 equals 7. We want to get rid of this negative 3, so we minus 3 by both sides. So we get 7 minus 3 is 4. So negative 2, divide that by both sides, and we get negative 2 on the other side. So the solution is negative 2, comma 5. To confirm this, you're again going to set your absolute value to the other side of the equation. So just think back in the beginning when it was solve. We could do it, solve for absolute value 2x minus 3 minus 4 equals 3. We could solve it this way, or we could solve it this way. So here we know the intersection based on what we wrote algebraically was negative 2, so we go here negative 1, negative 2. and it hits the line there. And then 5. So we go 1, 2, 3, 4, 5, and that's where it hits it right there. And that's all for the lesson.